So, hello guys, my name is Max and welcome to a new video on my YouTube channel. Yeah, you can believe your eyes. I just want to start by thanking and welcoming all new subscribers I got over the summer and all old ones as well for sticking around with me for quite some time now. So I'm really glad for your support and kind comments and good suggestions on how to make these videos better. So some of you might be wondering why I haven't uploaded any videos for about 2 months now. So I just want to explain that before we start programming. So over the summer did I go back to my parents' house to work and stuff, and that's about 500 kilometers from where I live normally, so I basically couldn't bring my computer, which has the consequence that I almost haven't programmed anything at all for a couple of months. Except for some crappy web design for my personal site, that's actually starting to take some shape here. So I was debating if I should continue the tic-tac-toe game or start something new and fresh now when I'm back at my apartment, and as you can see on the title in this video, I go with later. So in this video today, you can call it the start of the second season of game development here on the channel, or we're going to program a simple Tetris clone using JavaScript and HTML. So by simple, I'm referring to some limitations for the game, like we won't have any menu screens and no effects, but these should be easy enough to add for yourself if you so wish. But enough of me babbling about, let's actually start programming here. So we can start by creating a new folder on our computer here, and I will call it Tetris, and just open that up with this is the source code for my homepage at the moment. So as you can see, I use DocBad for the backend of the site. But anyway, enough of that. So let's just open up this folder we created with Sublime Text, and I just got a text here. So 1 second guys, be right back. Yeah, so I'm back guys, so that. Wait. Yeah, we created this folder here called Tetris. Anyway, so inside of here, we'll create some more folders. So we'll have a CSS folder for all of our CSS. That'll probably just be one file, but whatever. Then we'll have a JS and a source folder, or CRC, where we will have all of our JavaScript code. And lastly, our REST folder or resources. We will have all of our image data and sound if you so wish to add that as well. Anyway, speaking of the resource folder, for this project we'll use another project as a base. So we'll use the graphics from this project in particular to facilitate our game creation here. Anyway, so I'll leave a link in the description of course to this Google code page, but then we'll probably directly want to go to the GitHub page and inside of bin and assets folder, just the files we are interested in. So for this we will use all of the PNG images, so just open up every file that ends with .png and then just use any method you want to copy them over to the resource folder of your project here. I'll just drag them into the folder since that's quite simple and quick. Yeah, so these should now be added to the project, which is good. So we will need some more files from the internet for this project. So we used the JavaScript inheritance system from John Resig that we used in the Astro games and all stuff like that to also facilitate our game creation to make it easier for us to make games and classes and all stuff like that. So just go to the second section and copy the source for the thing here had been developed. Anyway, so just go to the JS folder, create a new file, and call it class.js. Inside there, just copy that. So we have that done. And we'll also use module loader for this particular project. So just go to requirejs.org. I choose requirejs today because that's really simple to use. And it only requires you to download the latest version and you're good to go. So just copy that, click the minified download, sorry I can show you again, download here, then the minified button there, and just copy content of the file and create a new file here that we call require.js, and inside of there just copy the thing, or paste the thing you just copied. Anyway, so we're good to go here. So we can start by creating our game now actually. So we will just create our index file and our CSS styles.css file. That but we can close that down for now. So we just create our HTML code here. So call, say the title, STC, maybe a simple Tetris club, like that. And in the body, we'll add all of our script dependencies today. So we'll first of all import the class.js file. Then we'll have our require.js file here. So require.js. Then as attribute here, or a data attribute to the thing, we declare this data main attribute. And this is sort of the file we first want the program to kick off here. And that will actually be in the source directory as well. So let's create that file called main.js. And inside of here is log out message for now, so console.log test. Just to see if our setup is correct so far. So let's open this up in a browser. There it is. And look, inspect elements on the page, open the console. Yeah, this test message is written out. So that means that it at least works so far. Yeah, so let's include another file before we include a require.js file though, that we will call engine.js. That's just basic namespace for our game here that we will use in order to facilitate game creations in the future and this game as well. And this engine that we soon will create will use this canvas tag here as a starting point for the game. So you have to include this canvas tag as well as this script in order for our games, both now and in the future, to work here. Anyway, so let's create this file. So I just call it engine.js, and engine is maybe a strong word here, because everything it will take care of is abstract out some usage on the canvas, take care of input for us, and content loading. So just create these global variables here, or they will be included globally to the page. Then create this closed function scope, where we'll initialize all of these objects. So we can start by the canvas. We can actually make that also equals to a closed function scope here. So we just say var c, set that to an empty object like that for now. That later will return here. Then we can add properties and methods to that object to like make them globally available for us. Anyway, so we will declare our frame. We will use like 2 canvases in order for it to work, so like scale content with pixel perfect resolution. So the frame will be equal to the document.get elements by tag name canvas 0. What this does, it gets all of the canvas elements on the page, and then this part here will return the first it finds. So the first canvas tag on the page will be equal to the frame of our canvas here. Then we'll have the frame context. That will just be frame.get context 2D, like that. And we have our view object, and that will just be document.create element canvas, like so. And that will also need a context, so it's a view.get context 2D. Then do we need some other private variables here? We have the frame width, frame height, view width, view height, and then our scale factor that will set to 1 at the start here. Anyway, so now when we have done all of that, we can add some properties to the C object here. So let's add a frame, the view, and the context to be globally available here, like that. And then we have this flip function or method on this that we also want to create here. And what it does, it will basically clear the frame. So you say frame context dot clear image. And we want to clear the whole image, so 0, 0. This is the starting coordinates, and then the width and the height of the rectangle we want to clear. So that will be equal to the frame width and the frame height. And then basically what we want to do is we take this dot context, so we can use this will point towards the C object, which has the property name context, and that's of course equals to this object up here. So you can say, oh, sorry. Before we do that, though, we want to draw an image to the frame context. That we go to the view. So say just this.view, which of course is this object, which is this object, and we want that to fill the complete canvas. So you say frame width and frame height again. Here, then we also want to clear. It should be clear rect, not clear image. Sorry for that. We also want to clear the rect here as well. So we say 0, 0, view width, and view height. So what this does is it will scale up the view of our canvas and draw that to the frame context. Yeah, this will be clear in a moment here. Anyway, we'll also declare or define some properties on the C object here. So we have a width object, then a scale, and of course a height as well. So these properties will have a getter and setter. So you can do those in JavaScript using this object.defineProperty method. So the first argument is the object you want to define the property to. The second one is the name, and then the third argument is a object with a get property and a set property that's equal to two functions that will be called when we are getting and setting data to this object. So we can just copy those in here as well, like that. So let's just see here, and then we can say this c.scale equals to the scale, just so we populate those things. Yeah, when we start the game here. So we can start with the width here actually. So here we'll say this.view.width equals to the w here. Then we just say this.scale equals to the scale here again to correct these variables and all the stuff like that. And then when we want to set, I got those the wrong direction here, of course, set get, set, and get. I really don't know what I'm doing right now, but anyway, yeah, here we go. Hope that was clear. Anyway, view.height equals to the h here, this dot scale equals to the scale, and here we just want to return view height, sorry, and here we want to return view width like that. And then the scale is a little bit more complicated, but we also want to set the scale object equal to s here. The view width equal to this dot view width. View height equals to this dot view dot height. The view frame width should be equal to this dot frame. The width should be equal to the view width times s, and then the frame height is the frame the height equals the view height times s, like that. And then one final thing that's really important if you want pixel perfect scaling is to set the image smoothing enable to false here on the frame context. And just for it to work in more browsers, we'll create this sort of polyfill to enable to disable these on with some prefixes there. So yes, we can create this array here with some prefixes, and then we can say for each, which take a function as an argument, and then we'll say framing context b here will have the values of O, MS, MOS, and WebKit, so that we can just concatenate that string with the image smoothing enabled You set that to false right there. And don't forget to change it to a capitalized I there. Anyway, and then in get, we just want to return the scale factor. So if this works now, we can check in the just reload the page. We don't get any errors, so that's good at least. So you can see here. Let's add some styling to the canvas, the page here, so we can add a border for now at least. And I reload. Oh, so and then we just want to link that to the page, of course. We say a link CSS styles CSS. See, yeah. So we can now see we have the canvas on page. So let's see, we can change the width and height and stuff. So let's set the width to 100 pixels. See what that looks like. Yeah, that seems to be working. Then let's set the scale to like 4 or 2 maybe. Then that should be twice as big. Yeah, and that seems to be the case there. So that's cool. The cool thing is, if let's say we draw an image, we say fill rect 0 0, or even better, let's draw an arc method. So we say begin part c dot fill maybe c dot arc. We say 10 10 5. And then between which angles, of course, so you can say 2, you can say 7. That should be it. So let's see. Oh, and then we of course want to say call the flip method on the canvas in order for it to show here. Yeah, so that seems to be working here. There you can already see that it worked, but let's just prove my point here. So we say canvas high, and let's set that equal to 20 maybe. So you can see when we increase the scaling factor that the graphic still is sharp here, which is good if you want to like make pixelated games like retro classic games and all stuff like that. And if we wouldn't have made it with the image smoothing enabled, we can disable that feature, and then you can see what it will look like. You can see here that it will be this all smoothened out and don't really look good. So that's why we use this. We declare the canvas the way we have done up until this point here. Anyway, let's get rid of all this and let's get the require JS up and running. So we can start by require JS. We can start by declaring some configurations. So we can say the base URL, we can set that equal to the JS folder, and this path here, of course, relative to the index page. We'll also declare some paths. So we can declare a shorten here for the source folder, which is of course in the just like this. So we don't need, then we can just type when we want to include modules. We can just declare it like this. You can say like source canvas canvas instead of like doing that. So that's just a bit of convenience here. Anyway, so we start off the game by requiring the source game file like that. So we say function game. This is the way module loading works in in the require.js. So that will look in the source folder and find a file that says game.js or and so on. Then that will put that into this object here, whatever that path returns. So then we can say, for example, say var app equals game.extend, the syntax from the simple JavaScript inheritance system. And here we can say like init function. Here we can set a we can set the size of the canvas and all stuff like that. Yeah, just to see if it works here. So then we can specify a window on load event. Yeah, let's do that. and here we just want to create a var game equals new app, and then game.run maybe. So for it to work, we'll need to create this game file that we haven't declared yet. So define a new module. So we say define function like that, and here we just want to turn game, which we declare up here. So we say var game equals class extend, and it's just to make sure it works here. So let's create the run method, and then we just log out running for now. So let's see if it works. So let's reload the page. The object on load didn't really seem to work here, so let's see. Let's actually remove that. Let's do it like this instead. Yeah, so now we can see that that works at least. So that's cool. So we now have the basic game up and running here. So let's continue here with the engine now. So let's actually move the input after the content here just to like give a visual way of how we create this game. So we'll leave the input for the next video, I guess, but we can create content loading now. Yeah, so let's create this content variable here equals to this its own function scope here. If I can hit escape, that would be great. Yeah, so we can say var c again, why not? And this c of course is really different from the one we have above here. So what the context will need, it will need an array of files that will create like this, and then we'll have a has load variable, a counter, and load count equal to 0 like that. Then everything this function need, at least for this game, we can extend this engine later when we'll need more function, I guess, is just to have this load function that will take a name and a source, where we say that the source is equal to the source or the name. So we can give, if let's say we just give this function one argument, we give it the source for the file we want to load, then the name and the source will be the same thing here, basically. Then we just take this switch statement on the name, the source dot split on the dot pop, so that will give the file ending the file prefix. So then we have all the cases here. So we say var png, so to like load images. We can say that we want to load GIFs as well. Let's say we want to load JPEGs for some reason. Let's just break that, and then let's say that we want to load OGS, MP3s, and waves, like that. And then for, let's say in future, that we want to load JSON and TMX for like file maps and for maps and stuff like that. But anyway, the thing we are interested in today is the images, so that's the one we will do in for the Tetris game. Then we can extend this in the future. Anyway, so we can save our image equal new image like that. And then let's just say that the image on load event will be equal to a function, which on calling will increment the load count like that. And don't forget, we can say it like this. Let's see how do we want this to do this. We can say file count plus plus like that. So let's change this to file count. Yeah, this is good. Yeah, so each time we call this method, we increment the file count, and each time we load a resource, we increment the load count. So that's good. And then we just set the source of the image to the source argument, and then we just set the files with the name here equals to the image object, like that. Then to just like get resources, you can say c.get set that equal to function that take a name as argument, and then we just return the files at the name like that. And then let's also have a progress function that we just return how many files we have loaded and divide that by the number of files we have added to the project. So let's say when this progress function returns 1, we know that all of the files are loaded on the page. Alright, so that was it for the content loader. So let's see if it works. So we can just go to the app here as well, again, and then we can just say, we can say content.load. We want to load a back image. That's in the resource folder. And we just call back.png. So let's just yank that down there, and then we have the numbers file and the blocks file. Like that. So you can call this blocks. You can call this numbers. So let's see if it works now. So let's open up the browser again. Yeah, that seems to be working. We have no error messages at least, so that's cool. So basically what we want to do now, when we have loaded all of these things, is we want to create this tick function, which we will extend here from the game class later. But for now, let's just fill this out. So we can say if content.progress equals to 1, then we just want to draw, we can say canvas.context draw image content.get. Let's say we want to draw the back image at 0, 0. So let's just implement this tick function and run function and other stuff like that. So we can start with the tick function. That just look like this for now. Where we console where we want that it should be overridden. Child class like that. And in the run method, probably guess what it will look like now. What it will look like now. Anyway, so here we just create this loop function. Say function loop. Then we'll say this dot rec frame equals to, let's remove one underscore, equals to the window dot request animation frame, the loop like that. Whoa. And let's paste this here as well. Oh, one. Yeah, now it should be copied. Yeah, cool. And of course change this to self, where self equals to this. Yep, so that should be the loop function working at least. So let's see here. Whoops. Well, let's see if the tick function is called even. So let's just log out the message, console.log test. Yeah, the test message written out. Then why isn't it's working? Oh, maybe it is. Maybe it's too small to see here. Yeah, that's probably it. So let's just increase the size of the canvas here. So it seems to be 480 by 272 pixels. So let's set that. So that's done at least. So the size is the right size here. Now let's see. No, still doesn't draw. So 1 second guys, let me just debug this and I'll be right back. Oh, I'm really so stupid sometimes. Of course, we need to flip the canvas in order for it to show. So just go down here to the loop function. And here, basically what we want to do is we want to call the canvas flip. So we won't forget that in the future. Yeah, so we now can see that the the graphics of the game is actually drawn to the canvas here. And as you can see here, we can increase the scale factor and all the stuff like that, and that will fit the game to the, or that will scale the graphics of the game for us. So that's really cool, but let's keep it for one for now. And we can make it dynamically scale later. Yeah, so what can we do from here? Well, let's actually implement a run and a stop function for the game here. So we can call it like this. And here, in the run function, we can say if this start running, then we want to return, of course. Else we want to set this start running equals to true, like that, in order for it to work here. Now you can say if we have requested request animation frame, then we just want to call the window.cancel animation frame. I think that's the right method. I just need to Google that real quick. Cancel animation frame. Yeah, that seems to be the case. Yes. And this won't work in all browsers. We'll create some polyfills up here soon. Don't worry. Then we want to set the rec frame to null in any case. And then we want to set the running variable to false here. So that's cool. And then just in the main here, we will bind the window.onBlur event, or blur event to game.stop.bind game. So it will call with the game context. Then we say window.onFocus to the game.run.bind game. So will this work now? So let's see. Let's just log out the test message, console log test again, and that should be written over on console. And then if we click down here, whoops, maybe it isn't. Yeah, now we can see here when I click on console that the game is actually stopping, or the test message isn't written out over and over again in console. So that means that this works at least. So that's good. Let's just wait for it to sort of kick in here. Yeah, that's the case here. Yeah, so we now have that done. Let's actually, let's leave the game for this for now. Let's just add some polyfills here for the window request animation frame. So one I really like is just to declare the vendors up here. So say var vendors, say var vendors equals to Opera, MS, MOS, and WebKit again, of course. Then we just loop through all the vendors, so say var I equals vendors.length, and then we say I minus minus and not window.request animation frame, like that, and then we say window.request animation frame equals square brackets, vendors, I can actually say var v equals vendors at I, like that, v plus request animation frame, change this to a capitalized R, of course, and then set window.cancel request animation frame, window v plus cancel animation frame, or window v plus cancel request animation frame, because there are two different versions of the cancel animation frame. So we should now have a working polyfill for window request animation frame. So that's really cool. That's nice and all. So let's actually close down the game for now. So basically what we want to create here is we want to say this.has load, set that equal to false. Then inside of here we say if this.has load, then we want stuff to be called here, else we want to say this.hasLoad equals to the content dot load progress equals to 1. Just to make it a bit more efficient here, so we don't need to do this check every frame. And here we can say if this.hasLoad. So if it is the first time this block of code is called, then we also want to set this.Tetris equals to a new Tetris game, like that. And the Tetris game we can create there in the source folder as well. So we say new file tetris.js, just define this module function like that, var Tetris equals class.extend, of course, return Tetris like that. Then just include it here as well, so you can say source Tetris, and don't forget the Tetris here as well. So let's reload it, see if it works. Yeah, no error messages. So then we'll say if this.hasLoad, then we'll set this.Tetris.handle inputs. And you can put input there. Okay, this.Tetris.update. That, and this.Tetris.draw canvas of context. That, so let's just create those methods. We say handle inputs function like that, and then we have update, I think we call it, function, and then lastly draw function, context like that, and here we can say this.back equals content.get back like that. And here we can say context.draw image this back 0 0. And I saw that I misspelled here, so let's see. Yeah, now we're back where we had before here, but we have abstracted out some parts of the game here. Anyway, so let's actually do one more thing in this video as well. So let's just add all of the scores here to the page, and then let's call it a day, and let's create all of the logic in another video. So for that, we'll create a new module as well that we will call numfont.js, and I should really have a snippet for this, but anyway, let's just clear this function numfont equals class.extend return numfont like that. Then the Tetris, it will require this module, so we say source numfont that, of course, set that equal to font numfont, and I can say this dot font equals to an object, and let's just see which numbers we have here. So let's start by adding the gray font. So we're going to say gray equal to a new num font, and what will this take for arguments? Well, you can say that it will take an image object and then a y position, since it will just be for this file here. So take a y what do you say, a y position on which row it's going to take here, of course. Then the height of each of the numbers. So let's just open this up with the simple image editor here, so you can see see how wide these letters are. So they seem to be 9 pixels, I think. Just check one more time. Well, the whole thing is 72, so we can divide 72 by 1, 2, 3, 4, 5, 6, 7, 8. Yeah, there are 9 tall, so let's just add that to the second parameter there. So let's just create a constructor to take in all these, say init function, and I don't know why I have this in the inputs. This should of course be in the init method. I thought something looked strange, and yeah, there it was. Should still work though. Yeah. Anyway, so num font, it take image, then y position, and height. So that's cool. So you can say this dot image equals image, this dot y equals y, this dot height equals h, and then this dot width equals image dot width divided by 10, because there are 10 numbers, 0 to 9. Anyway, and here we can say give it one method that's called draw. So just say which number it should draw. So say which number it should draw, of course. But maybe take a context first. So which context it want to draw the number to, then an x and a y position, and a padding, an optional padding. Okay, so we just set the number equals to this stuff, and you can say if the padding is existence, if the padding exists. Yeah, I'll leave that for now. I just need to just check some stuff before I do that though. Now we can say context.draw. We can say for. One moment, guys. I just think how we'll do this, and I'll be right back. Yeah, so I'm back. So I found out the method how to do this. Anyway, so we just loop through all of the numbers in the all of the letters in the number. So you say number length like that, I is less than len, I plus plus, the regular stuff here. And then we say just say n up here. That's a bit more efficient. Alright, so say var n equals num at I, like that, and then we of course want to pass an integer of that number. And then we basically just draw an image. We say context.draw image, this dot image, to the width times n, and the this of y, of course, for the y position, and then the width, and this the height, then the x and y position where we want to draw it, and then the width and the height again. And that should be it. And then we just increment the x position with the width of each of the letters. And for the padding, it's a bit complicated. I just googled it and I found what I was looking for. So basically what I want to do was want to say the length is greater or equals to the padding. Then we just want to keep it as it is, so we just say we just put it equal to the none, of course. Else we want to create a new array with the padding minus the length of the number plus 1, and we just want to join that by zeros, and then we want to concatenate that with the number array. So that should be working here. So let's see if it works. So we can go to the Tetris again, and in the draw method, let's just say this.font.gray.draw. I want to draw the context, and let's say you want to draw the number 42. Then at which position, so let's say 10, 10, and let's say that we want to pad it with 8 zeros. So let's see if it works here. Yeah, so here you can see the number 0000042 working fine here. And if you say 5, it should pad it with less zeros, and so on and so forth. Anyway, let's implement all of the different colors of the font we had, and I said there were 9 of them, so 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's just add those as well here. And let's say which numbers do we have. So we have like cyan, red, blue, cyan, red, blue. Yes. Let's see, cyan, red, blue. What do we more have? Orange, green, yellow. Orange, green, yellow, purple. Yeah, maybe I miscalculated. Let's just keep it like this for now. Let's just make them work like that. Then we just add 9 here to the previous one all the way down, so say 18, 27 of course, 35, 44 I guess, 53, 62 and 71. That doesn't really look good at all. 71. Oh. Of course, they're all 9 pixels tall, but the one we want to change is of course here. Here we want to say 9, 18, 27, 36, 45, 54, 63. Yeah, this looks a lot better. Alright, so let's see if it works. So we can try to draw the cyan color as instead. Yeah, that's it working. Red. Yeah. Blue. Yeah. Orange. Yeah. The green one. Yes. And the yellow. Yes. And lastly the purple. Purple, I said. Yeah, that's really fine. So now everything we need to do is just to figure out the position and where to draw them, and what to draw at that particular point. So I just create this data object that will create like this. And if you don't know that much about Tetris, then each piece has its own name. So this, for example, is called the L piece, I guess, because that looks like an L. This is I, T, this is S, Z, O, and J. So let's just create those. So say L, I, T, I guess, then S, Z, O, and lastly J. And all of those we basically want to set to 0. Yeah. And let's create this total as well here. If you look in the on the image just here, you can see that last we have how many pieces in total we have. Alright, so let's see. They seem like they padded with 5 numbers. So 5 is good here. And the last one seems to be padded by 6. And that one was drawn gray. So let's just say that. So we have that done at least. 6, yes. And what now we want to draw that was this data total. That. Then at which position. Let's see. So let's just open up this stuff again, but this time we can open up the this, I guess. Yeah. So down here I can see which position I want to draw him. So this is somewhere close to 420 by 220. So let's see what that looks like. 420 by 220. Let's reload here. Yeah, almost good. Maybe we should down one and write a bit more. So let's see, 21. Yeah, even more. 5 maybe. Yeah, that seems to be the case. And yeah, so I will just do the rest then, and then we'll call it a day. And I'll just do the same way here, like I look here on which position I want to draw them, and yeah, that's about it. And I don't think that will be that fun to watch. So yeah, see you guys when I've done that. Yeah, so I'm back, guys. So this is the position I figured out. So you can just copy these numbers if you're following with the video here. So let's see what they look like on the page. And basically, when let's say I change from this to 1 here, you can see how the correct post on the thing are updating. Yeah, so thank you guys for watching, and I see you in the next video. Bye.